Chapter 9.8 Application Problems. In these application problems, we will work with another work rate. The work rate and then the speed questions. Okay, first of all, let's check the example here. A painter can paint a ceiling in 60 minutes. So one painter, if a painter paints, it takes 60 minutes to complete one job. 60 minutes, and there's another person. And this painter's apprentice can paint the same ceiling in 90 minutes. So this person, takes 90 minutes to complete, painting the ceiling. Then how long will it take if both people work together? So let's look at this one. The work rate times the number of the time for them they worked will be the work done, the part of the work completed. So work rate is, this is important, work rate. Okay, let's say here is person A. Okay, one person completed, it took 60 minutes. It took 60 minutes. Then let's divide this one into 60 pieces. Divide into 60 pieces. Then each piece is the work rate. So this guy can complete 1/60 job. Will be done per hour. That's the work rate. Not hour, per minute. Can you see it? So in order to complete one job, let's say this one rectangle is one job, it's one ceiling. And since it takes 60 minutes divided into 60, so that each piece is the part that he can complete per minute. So this is the work rate. So 1/6 of the job, one complete job will be done per minute. Okay, the second person can complete, it takes 90 minutes. It takes 90 minutes. So divide this one into how many pieces? 90 pieces. There are 90 pieces. PICS. 90 pieces. So each piece is the work done per minute. So this guy can complete 1/90. 1/90th of the job will be done per minute. Okay, so that is the work rate. And then once you complete it, these guys work together, then this will take X minutes. I don't know how many minutes. Let's say it is an X minutes. It takes X minutes. Then we will divide it into X pieces. So each piece is the work done per minute if both of them work together. So 1/X job will be done per minute. So we have an equation like this. So from this equation, why don't we just add? So each minute, the first person can complete 1/60 job will be done per minute. Okay, per minute, right? Per minute. And then for the second person, this guy can complete 1/90. So 90th of the job will be done per minute. And then if they both worked, then every minute they can complete 1/X job will be done per minute. So this is the equation. This is the equation of the job done per minute. So from this, what we want to find is X, isn't it? X. How long does it take? X. The equation on the right side. X. So using this equation, we can find an X. Or we can make another equation from this. The work rate times the time worked will be the part of the work completed. So the work rate for the first person is 1/60. Job will be done per minute. So multiply this by, let's say it takes X hours. If both both painters work, then it takes X minutes. So multiply this by the time, which is X minutes. So A can complete this many jobs, and then plus the second person. The work rate for the second person is 1/90. 1/90th of the job will be done per minute. So how many minutes they work together? It takes X minutes to complete one job. So sum of these two works will be one complete job. So you can find an equation, either this equation or this equation. Actually, they are same. So you can solve for X from one of these two equations. So let's use the first one. From this first one, let's get rid of the denominators. How? Okay, find the LCD. What's the LCD? The LCD is 180x, isn't it? 180x. So let's multiply the equation by the LCD. Okay, multiply. We just want to solve for x, that's it. So multiply each side by 180x. 180x. Then using the distribution property, 180x times 1/60. 180x times 1/90 is equal to 1/x times 100x. And then cancel out the reduce the fractions. Then this will be 3x. And the second term is 2x is equal to 180. And then 5x is equal to 180. Then x is equal to 180 divided by 5. So x is 36. All right. So it takes 36 minutes if both painters work together. All right, how about the right-hand side? Okay, this one is, we do the same thing, isn't it? We do the same thing. What we do is, this is multiply the LCD. The LCD is this time 180. So multiply each side by 180. So 180 times 1/60x, 1/90x is equal to 1 times 180. All right, then this is equal to 180 times 1/60x, 180, 1/90x. This is multiplication. The multiplication is 180. Then you can reduce the fraction. So 3x plus 2x is equal to 180. Then 5x is equal to 180. And then x is 180 divided by 5. So x equals 36. Then the unit is minutes. So it takes 36 minutes to complete. So what is important is this. Okay, always draw a little rectangle, and if it takes, it give us the time 60 minutes, then divide the rectangle into 60 pieces. 60 pieces, then each piece is the work rate. This is the work rate. Okay, work rate. Work rate is the number of jobs done per minute or per hour, and so on. And then what we do is just add the work rate. So write an equation using the work rate. Or you can multiply each work rate by the number of, by the time. In this case, x minutes. Then you have another equation like this. Okay, example 1. There are two water pipes. One is small and one is larger. So, okay, the information is this. The small water pipe takes 4 times longer than the larger pipe. So let's say the larger pipe takes T hours. Larger water pipe takes T hours to fill a tank. Then the smaller pipe, if the smaller pipe works alone, then it takes 4 times longer than the larger pipe takes. So it will be 4 T hours if they work alone. So why don't we draw a little rectangle? Okay, the little rectangle is this. Should I write it here? Okay. So this one takes 40 hours. So divide this one into 40 pieces. 40 pieces, right? 40 pieces. Divide into 40 pieces. I don't know what the value of t is. So each piece represents number of hours required. Number of jobs will be done per hour. So the smaller pipe will complete 1/40 job will be done per hour. Okay, the larger pipe takes T hours. So divide this into T pieces. So each piece is 1/T of the job will be done per hour. And then if they work together, okay, the second information is this. If both work together, with both pipes open, it takes 3 hours to fill the tank. So this one takes 3 hours. So we can divide it into 3 pieces. So each piece shows the work done. So 1/3 of the tank will be filled per hour. Right? So each hour it completes 1/3 of the tank. So using this, we can set up an equation. So find the time it would take the smaller pipe working alone to fill the tank. So if small pipe works alone, if only the small pipe is open, then how long does it take? That's the question. So we need to find T first. Then the small pipe will take 40 hours. So using the diagram, let's write an equation. Because the first one is 1/T. 1/T. Okay, the first equation is this. Okay, let me write 2 equations. The first one is 1/40 job will be done per hour. And for the larger pipe will complete 1/T job. 1/T of the tank will be filled per hour. So once they work together, it takes 3 hours. So 1/3 of the tank will be filled. Alright, so we have one equation. And then you can set up another equation. Actually, these 2 equations will give you the same answer. Okay, the second equation is the work rate. The work rate for the smaller pipe will be 1/40. The work rate is 1/40 of the tank will be filled per hour. So multiply this by how many hours? It takes 3 hours to complete. If both of them work together, it takes 3 hours. So multiply this by 3. And then for the larger pipe, it takes 1/T is the work rate per hour. So multiply this by 3 hours. because both worked for 3 hours. Both worked for 3 hours so that it filled one complete tank. So we have two equations. All right, the first equation is what? This is the equation. Let me write the information. This is the equation of work, equation of the work done, equation of the work done per what? Per hour. Okay, and then this one, this is the equation by multiplying the work rate. Multiply the work rate by the time for both pipes to complete one job. Will be one job. So you can write an equation. You can use either one of these two equations. Which one is best? It doesn't matter. Okay, I prefer the first one because first one is really simple. You can set up an equation of the work done per hour, per minute or per hour. So from this, the LCD. Okay, what's the LCD? We want to find T first. So LCD is 12T. So multiply the whole equation by 12T. So let's multiply. In order to find T, let's get rid of the denominators. So multiply the equation by 12T. Then the left side is 12T times 1 over 4T. 12T times 1 over T. 1 over 3 times 12T. Then we can reduce each term. So the first term will be 3. The second term is cancel out T, so 12. The right side is 4T. Then 15 is equal to 4T. Divide each side by 4. So 15 over 4 equals T. So now T is equal to 15 over 4. Okay, 15 over 4. Okay, wait a minute. All right, so if the larger pipe is opened alone, then it will take 15 over 4 hours. So what we are looking for is the small pipe. The small pipe takes 40 hours. So 4 times 15 over 4 is 15 hours. All right, if the smaller pipe works alone, then it takes 15 hours. It's quite a long time, huh? If larger pipe, small pipe both work together, it takes only 3 hours. But smaller pipe takes 15 hours to complete. Okay, for the second equation, you can try this and you will have the same answer. Okay, problem 1. This one is a little bit complicated. Okay, why don't you try first? All right, so there are two printers and the work rate for these two printers are the same. So they have the same work rate. So let's say if the printer one, both printers can complete one job for T hours. Okay, so every hour it finishes 1 over T job will be done. So the work rate, let's say the work rate is 1 over T is the work rate. So okay, let's say if a printer, only one printer complete, it takes T hours to complete one job. And they have the same work rate. So each piece, so divide this one job into T pieces. How many pieces? There are T pieces. There are T pieces. So each piece will represent the work done per hour. So that's the work rate. All right, and that the next information is, okay, both printers worked for 3 hours. Okay, both printers worked for 3 hours, and then one of the printer worked for 2 hours to complete one job. So one, okay, let's say P1. Okay, P1 worked for 3 hours. Both worked for 3 hours. So printer 1 worked 3 hours, and the second printer worked 2 more hours, so 5 hours. So that here is the work done problem. Okay, here is the first printer. The work rate is 1 over t. Okay, 1 over t job will be done per hour, and the first printer worked for how many hours? 3 hours. And the second printer, the work rate for the second printer is 1 over t, and then this one worked for how many hours? 5 hours, because it worked another 2 hours, worked for 5 hours. And then since both worked for this many hours to complete one job. So the first printer worked 3 hours and the second printer worked 5 hours to complete one job. So we have an equation like this. So work rate times the number of hours will be the work done per, will be the work to complete one job. It's the job done per. So both work together, so they complete one job. Okay. So let's solve t for this. So that's the question. That's the answer for this question. All right, then why don't we multiply t each side? So this is equal to 3 over t plus 5 over t is equal to 1. So multiply each side by t, the DLCD. Then from using the distribution property, this will be t times 3t, 3 over t, t times 5 over t is equal to t. Then cancel out t, so 3 plus 5 is equal to t, so 8 equals t. So t is 8. Okay, t is the number of hours done if each printer works alone. So it takes 8 hours to complete one job if each printer works alone. Okay, in this case, new definition, okay, uniform motion problems. Okay, when we say a speed, okay, for example, what is the speed of the highway? Then we may say it is 60 miles per hour. 60 miles per hour is the speed. Then this means, if we rewrite it, okay, 60 miles per hour, okay, 60 miles. So 60 miles is the numerator, per hour means over 1 hour. So speed means miles per hour. So we can write it as this. Speed is equals to, the numerator is the miles, which means the distance. Distance over, and hour is the time. Distance over time is the speed. Speed can be also speed. Speed is also, we say, a rate. What's the speed rate? What's the rate? So we have one equation like this. Okay, speed can be the equation for the speed is the distance over time. Distance over time. And then also from this one, distance. Then what's the distance? The distance is multiply each side by t. Then speed times time. And how about the time? From this one, the equation for time is, okay, divide this equation by s, so that we can find t. So t is distance over s. So using this speed equation, we have 2 more equations. So there are 3 equations that's related to speed. Okay, so make sure to understand this equation. Speed is equal to distance over time. And from this one, distance is speed times time, and time is distance over speed. Okay, speed means rate. Or you can do this way. Okay, DST. Write the DST, distance, DST. Okay, DST. Okay, write DST in triangle and draw a fraction bar like this. So this one represents that the distance is equal to, okay, the distance is equals to what? The denominator, ST. S times T. So see, we have D equals ST. And then S is equal to, look at this S is equal to, the other variables are D over T. So you can write it as D over T. Okay, finally, the time. Okay, from this one, the time is equal to distance over S. So you may have three equations using this triangle DST. Or you can have three equations using the definition of the speed. Speed is miles per hour, so distance over time. All right, then using this information, let's solve an example. Okay, let's say here's a river going down. River is going down. The water is flowing this way. The current is going from left to right. And the speed of the boat. Here's a boat. Here's the boat. The speed of the boat in still water. Still water means, the water is not flowing. Water is fixed. No water is flowing. So that the speed of the boat is 20 miles per hour. The speed of the boat is 20 miles per hour. And then when you go downstream from A to B, okay, let's say the distance when you go downstream is 120 miles. The distance is 120 miles. Okay, when you go upstream, if you want to go upstream, okay, the water is flowing this way. So the speed of the current, let's say the speed of the current is the C miles per hour. Okay, C miles per hour. This is the speed of the current. Speed of the current, the water. The water is going that way. So when you come upstairs, it takes T hours. Let's say, okay, when you go downstream for 120 miles, let's say it takes T hours. Then using the same T hours, when you go against the water, it takes T hours, and you came up 80 miles. Okay, so it took T hours to come against the water 80 miles. So using this, let's find out the speed of the current, C. All right, then look at this. They used it took same hours. When you go downstream and upstream, it took T hours. So using the equation T, the equation for time is the distance over the speed. Time is the distance over speed. And what is the speed of total speed when you go downstream? For the downstream, the total speed. Okay, when you go downstream, the total speed is the boat speed plus the speed of the water, speed of the current. So B plus C will be the speed for the downstream. Okay, this is the downstream. Okay, when you go up, then the upstream speed, okay, up. You are going against the water, so here's the boat speed minus C. So the speed of the boat will be reduced by the current speed. So B minus C is the speed of the boat when you go upstream, and then when you go downstream, the speed will be increased by the water, because the water helps the speed of the boat. So from this, okay, when the time for downstream is equal to time for upstream. So time for downstream is the distance of the speed for downstream, and the distance for speed of upstream when you go up. So okay, the distance when you go downstream, the distance is for 120 miles, and the speed for upstream will be the boat the downstream, sorry, is the sum of the both speed and the current. So when you go up, then the distance is 80 miles, and the speed will be b minus c. All right, then the both speed is 20 miles. The both speed is 20 miles, so 20 plus c, and then when you for upstreams, that's 20 minus c. So we have an equation here. This is the equation. So from this we can solve for c. Okay, let's do a cross multiply. 120 times 20 minus c is equal to 80 times 20 plus c. And then distribute. So 200. Actually, you can divide by 40. Okay, why don't we? Okay, let's just distribute, not to make you confused. Then 1600 plus 80c, and then combine and then collect the like terms. Minus 16 each side. Okay, minus 6. Okay, before you do the minus 16, why don't we move the variable terms together? So collect the variable terms first, and then move the constant term to the other side. That's 800, 200c. So divide each side by 200. So c equals 4. Now, the speed of the current is 4 miles per hour. That's the answer. So we in this case, the time for downstream and upstream are the same. So we'll make an equation based on the time. And the equation for the time is distance over speed. So we will use the distance and speed for downstream and the distance and speed for upstream. So we have an equation like this. So this is the equation. So starting from this equation, we can find c, the speed of the current. Okay, example 2. A cyclist rode the first 20 miles, first 20 miles with the speed, let's say it's x miles per hour. To drive 20 miles, it took x miles per hour, and then additional 16 miles, it takes the speed of the cyclist is reduced by 2. So the speed will be x minus 2 miles per hour. And the total distance is 20 plus 16 is 36 miles. And then to ride this distance, 36 miles, it took 4 hours. So that's the question. And we want to find the speed of the first section, the speed for the first 20 miles, and the speed 2, which is the speed for the last 6 miles. So let's find the speed 1 and speed 2. So from this, we can use an equation. Okay, look, the total distance is 4. The total hours is 4 hours. So it took 4 hours. Then the distance, the time, the equation for the time is, remember dst. So time is distance over the speed. So total time is 4 hours. So let's use the first section, because for the first section, okay, the time for the first section plus the time for the second section is what? 4 hours. Because it took 4 hours to complete this, to ride bicycle for these two distances, 20 miles and 60 miles. So for the first section, the time is distance over s. So the distance for the first region is 20 miles. So why don't we write it like this? So this is the distance for the first section over speed for the section, and the distance of the second part and the speed of the second part should be equal to 4. And the distance, the first distance is 20 miles, and the speed is x. And for the second distance is 16 miles, and the speed is x minus 2. 2 miles slower than the first speed. So we have an equation like this. So let's find x. X is the speed of the first section. Then from this, why don't we multiply the LCD? So the LCD is now x times x minus 2. So multiply this by the multiply x times x minus 2 to each side of the equation. Okay, so the first equation, the left side is 20 minus x plus 16 over x minus 2. All right, so let's multiply each side of the equation by the LCD and then distribute. So x times x minus 2 times 20 over x plus x times x minus 2 times 16 over x minus 2. Then this one is 4x times x minus 2. Okay, then from the first term, we can cancel out x. So we have x minus 2 times 20. The second term, x minus 2 cancel out, so x times 16. Then this one. All right, and then distribute. So 20x minus 40 plus 16x is equal to 4x squared minus 8x. Okay, this equation is quadratic. Since this is quadratic, why don't we put all the terms to the right? Okay, before we move, let's combine the like term first. This is 36x minus 40 equals 4x squared minus 8x. So move every term to the right. Then left-hand side is 0, 4x squared. Okay, so move everything to the right. So minus 36x, and then plus 40. Then 0 is equal to 4x squared. Combine the like terms, so minus 40. Okay, 44x plus 40, and then factor out for 11x plus 10. All right, we have a product. We want to find x. So one side is 0. So why don't we factor the right hand side? Then this is x times x. 10 is 1 times 10, and both negative makes positive 10. Then the sum will be negative x, negative 11x, so negative 10x, sorry. So that's 11x, negative 11x. Okay, that's the same as the second term. So the equation is 0 is equal to 4 times x minus 1 and x minus 10. Since the equation is 0, set each factor equal to 0. Then from the first factor, x equals 1. And from the second factor, x equals 10. Is that correct? Let me double check this one. All right, so s equals 1 and 2. We have two x values. So x is equal to s1, speed of the first part. So that is 1 miles. This is 1 miles per hour. 1 mile per hour. And the second part is 10 miles per hour. Okay, how about the second part? The second part is the speed is reduced by 2. So this means if s equals 1 mile per hour, then this is negative 1. And negative 1 does not make sense, right? Okay, for this, okay, for s equals, now if s1 equals 10 miles per hour, S2 is equal to S1 minus 2, which is 10 minus 2. So S2 is equal to 8. So S2 is 8 miles per hour. So from the value 1 does not make sense because S2 cannot be a negative number. So we cannot allow, so this one does not make sense. And then when S1 is 10 miles per hour, and then the speed of the second part is 8 miles per hour. Okay, problem number 2. Okay, there's a lake and a sailboat is going back and forth. So the lake is 6 kilometers wide, so the distance 6 kilometers. And the speed when you go to the right, let's say it is X miles per hour. But when you go from right to left, the speed is twice the rate, sailing to when you go to the right. So there is 2x. 2x will be the speed when you go from right to left. And then the total time is 3 hours. So going back and forth is 3 hours, takes 3 hours. And then find the speed from left to right. So find x. So since we know the time, okay, the time function, what's the time function? Okay, dst, remember dst? Okay, dst. So from this, the equation for time is what? Distance over speed. The total time is the time going from left to right should plus the time going from right to left is the total time, which is 3 hours. So using this one, we can write an equation. Distance over speed for going from left to right, plus this is for left and right. Left to right should be equal to the distance from right to left. So that equation is equal to 3. So we have an equation. So okay, let's say this left to right is d1 s1, d2 s2. So time 1 and time 2. Let's use time 1 and time 2. Time 1. Okay. So time 1 plus time 2. Okay, time 1 is left to right and time 2 is right to left. So from this equation, the distance is 16 miles and speed from left to right is x miles per hour. And the distance from right to left is same distance, 16 miles. And then the speed is twice, so 2x. So that is equal to the total time is 3 hours. So using this equation, let's find x. So x is the solution. And LCD from this one, what is LCD? LCD is 2x, right? 2x. So multiply each side by 2x. So I will multiply the equation by 2x. All right, then distribute. So 2x times 16 over x. 2x times 16 over 2x is equal to 6x. And then we can cancel out x. So this is 32. Is it 16? Wait a minute. Sorry, 6 miles per hour. 6 kilometers. All right, the distance is 6 kilometers, not 16. 6 kilometers. Okay, 6 kilometers. Okay, so this is 12 plus 2x cancel out. 6 is equal to 6x. Then 18 is equal to 6x. Then 18 over 6 is x. So x equals 3. So this means x equals 3 hours. So x is the speed from left to right, and S1. So the answer is 3 hours. It takes 3 hours. Oh, wait a minute. We are looking for what? Okay, we are looking for the question is find the rate of the sailboat going across the lake. So find the speed from left to right. All right, the speed from left to right is not hours. That's 3 miles per hour. Sorry, 3 miles per hour because x is the speed, 3 miles per hour.